Okay, see students, in this question number 8, in right triangle ABC, right angle at C. So this means this is triangle, right triangle ABC, ABC, right angle at C. So this is right angle. Okay, so this is given in the question. Right angle at C. M is the midpoint of hypotenuse AB. This M is the midpoint of this hypotenuse AB. C is joined to M and produced to a point D such that DM is equal to CM. This is given that DM is equal to CM. This is given to us. Okay. Now, what is the question? Point D is joined to point B. Point D joined to point B. Alright. See figure 7.2. This is 7.23. Show that. First part it is saying triangle AMC is congruent to triangle BMD. Okay, so I have solved all the 4 parts separately, students, in separate slide, starting with first part. So we have to show that triangle AMC is congruent to triangle BMD. Okay, now see, in triangle AMC and triangle BMD, this notation is of triangle, already told. By this time you should be thorough with this. In triangle AMC and triangle BMD, DM is equal to CM given. Okay, this is see triangle AMC, right students, in triangle BMD. Okay, this is already given to us. DM is equal to CM. It is already given to us. Okay, then angle CMA is equal to angle BMD. See angle CMA. This angle is equal to angle BMD. Why? Because it is vertically opposite. Okay, these are vertically opposite. See here, if I take these two, suppose, so this angle and this angle is vertically opposite. If I take here, so this angle and this angle will be vertically opposite. So this is vertically opposite angles. Okay, let me erase this. Okay, so these are vertically opposite angles. We studied all the different types of angles and lines and angles. So nothing difficult here, very easy, students. Alright, now M is the midpoint. Why? Because it is given here. See, it is given M is the midpoint of hypotenuse AB. Okay, M is the midpoint of the hypotenuse AB. Okay, therefore AM is equal to BM. Okay, this AM will be equal to CM. So I will write this notation. Okay, it will be easy. It is not given in the question, student, but you should know this. Okay, this notation. Okay, and how we can do. Suppose if I say, if I take this line segment. Okay, if I take this line segment 4 cm, and if I say this point is a midpoint, this means this length will be 2 cm and 2 cm. It will be divided equally, right? It will be divided equally. When I say that anything is the midpoint, this means it is in the middle. Alright. Similarly, here when it is saying that M is the midpoint, this M is the midpoint of AB. This means the length of AM will be equal to length of BM. Okay, this AM will be equal to BM. So that is this notation. M is the midpoint of AB. Therefore, AM is equal to BM. Okay, clear? Now, if you see carefully, we have got side. Okay, we have got angle and we have again got side. Therefore, by side angle side congruence, what is SAS? Side angle side congruence. Triangle AMC is congruent to triangle BMD. So simple, students. Okay, for congruence we need 3 things. Okay, it can be side angle side. Okay, it can be angle side. All these things. Okay, we have to check different type of congruence, but basically 3 things. Okay, whether it is side, whether it is angle, whether it is side. Okay, another congruence like which I have explained you. Okay, it can be anything depending upon the properties in question. It can be side congruence. So 3 things we will check. Whether it is SAS, whether it is SSS, different types of congruence. Okay, RHS congruence, depending upon the question and what is given in the question, we will check. I hope first part is clear. Now starting with second part. Second part, it is saying that you have to show angle DBC is a right angle. Okay, angle DBC. This means you have to show this B. Okay, DBC. I already told students when it is saying angle DBC, ADF, so we have to check for the center part. Okay, so angle DBC. Okay, so we check for this DBC. Okay, students. Okay, so in second part, we have to show that angle DBC is a right angle. Okay, angle DBC is a right angle. This angle. Okay, So we're starting with the second part. I hope you have followed first part. Now starting with second part. Okay, in this we have to show that angle DBC is a right angle. DBC. Okay, this we have to show that this is 90 degree. Alright. Angle ACM is equal to angle BDM. See, angle ACM alright, is equal to angle BDM. Okay, but CPCT, and these are also alternate interior angles. Remember this. Okay, these are also alternate interior angles. Okay, and in the previous first part we have shown that triangles, this AMC and BMD are congruent, so by CPCT also. Okay, therefore DB is parallel to AC. Understand this. Okay, these two angles, angle ACM will be equal to angle BDM by CPCT and by alternate interior angle also. Therefore DB is parallel to AC. Okay, DB is parallel to AC. This means angle DBC plus angle C is equal to 180 degree. Why? Because co-interior. Suppose students, we did all this in lines and angles. If I take this angle and this, so A plus B has to be 180 because they're co-interior. A plus B has to be 180. And if you check this, these are parallel lines. Okay, and co-interior angles. Okay, the sum has to be 180 degree. Okay, so angle DBC plus angle C is equal to 180, right? But because they are co-interior angles, it is already given to us angle C. Angle C is how much? It is 90 degree. Okay, it is given C, right angle at C. So that is why C in this green notation. That is why I did this green notation. It is already given to us in the question that angle C is 90 degree. So angle DBC, you can write this if you want. Angle DBC plus 90 is equal to 180 degree, right? So angle DBC is equal to 180. This plus 90, when it will be transposed on the right side, it will be minus. So 180 minus 90. So angle DBC is equal to 90 degree. Hence proved. Okay, 90 right angle is always 90 degree. Right angle. Okay, students. In this way, second part. Now we will proceed with the third part. Third part says that you have to show triangle DBC is congruent to triangle ACB. You have to check for triangle DBC. Which triangle DBC? DBC. Okay, this triangle is congruent to triangle ACB. ACB. Okay. Now DB is equal to ACY. DB is equal to ACY because CPCT, and we have already proved triangle AMC is congruent to triangle BMD. Okay, in the first part we have proved this triangle AMC is congruent to triangle BMD. Okay, so therefore by CPCT, corresponding parts of congruent triangles. Okay, so DB will be equal to AC, right? Then angle DBC is equal to angle ACD. Angle DBC is equal to angle ACD, both 90 degree. In the previous part, we have already proved that angle B is 90 degree and angle C is 90 degree. It is given in the question C here, right angled at C, right? So BC is equal to CB, common. This BC or CB, it is common. Therefore, by SAS congruence, triangle DBC is congruent to triangle ACB. Very simple, students. See again, DB is equal to AC. Why? Because we have already shown that triangle AMC is congruent to triangle BMD, first part. Okay, so DB is equal to AC. You follow me? Okay, students. And angle DBC is equal to angle ACD, both 90 degrees. Angle C is 90 degree because given in the question. And in the previous part, we have already shown that angle DBC is 90 degree and BC is equal to CB, common. Therefore, by SAS congruence. Okay, by SAS congruence, triangle DBC is congruent to triangle ACB. Simple, students. Okay, I have simplified for you so that it is easy for you students to understand and solve the questions. Okay, so in your last part. Okay, in your last part you have to show that CM is half of AB. Where is CM? This CM is half of this AB. Okay. Triangle DBC is congruent to triangle ABC. Okay, proved in third part. See in the previous part, we already proved triangle DBC. Okay, is congruent to triangle ACB. We have already proved. Okay, so triangle DBC is congruent to triangle ABC. So what happens? DC is equal to AB. Where is DC? This DC. Okay, this DC will be equal to AB. Correct? By CPC, correct, students? Okay. Then this DC. Okay, DC I can split as DC. I can write as DM plus CM, or MC. Same thing. DM plus CM I have written. See, DM plus CM is equal to AB. Correct? It is given in the question that DM is equal to CM. See, it is given DM is equal to CM. So in place of DM, I will write CM in this equation only. See this equation A, students. See equation A, DM plus CM is equal to AB. Okay, DM plus CM is equal to AB. But it is given that DM is equal to CM. See, DM is equal to CM. It is already given to us, right? DM is equal to CM. So in place of DM, I am writing CM. So CM plus CM is equal to AB in this equation A. CM plus CM, 2CM. Okay, this is very basic, students. X plus X traditional algebra is 2X, right? Y plus Y algebra. So similarly, CM plus CM is 2CM is equal to AB. Now this is in multiplication. When it will go on the right side, it will be in division. So CM is equal to half of AB. Hence 2. Okay, so this is the simplest way, students, and I have simplified for you so that you don't find anything difficult. You can solve questions easily. Okay, now do this, and the remaining question which I left, you can complete that. This was the last question which I have solved. Okay, so you can complete the previous questions. Okay, and I'll tell you few more congruences, and then I'll start with the next exercise. Alright, students. So in this way you will complete RHS congruence, students. Okay, see here. So what do you understand by this RHS congruence, students? I think I had already explained you RHS congruence. I already explained when I started with the first session only. I explained you. So right angle, hypotenuse, side. I am repeating again. Right angle R. Okay, right angle, hypotenuse, side. Okay, so this is right angle, hypotenuse, side congruence. So see triangle ABC and triangle DEF. Okay, you can clearly see. This is right angle at B, this is right angle at E. So angle ABC is equal to angle DEF, 90 degree, correct? Okay, hypotenuse. Okay, AC is equal to DF, correct? BC is equal to EF. Okay, side BC is equal to EF. Then triangle ABC will be congruent to triangle DEF by RHS congruence. Alright, students. Now properties of a triangle. A triangle in which two sides are equal in length is called isosceles triangle. I repeat, students, in which two sides, you can clearly see, two sides are equal. Okay, that is isosceles triangle. Okay, that is isosceles triangle. Okay, so triangle ABC is an isosceles triangle with AB is equal to BC. This notation, students, AB is equal to BC. Suppose if I take any other triangle, okay, suppose if I take this triangle X, Y and Z. So XY is equal to XZ. Okay, it can be any two sides. It can be XY and YZ, any two sides. Okay, so I have taken AB and AC. Angles opposite to equal sides of an isosceles triangle are equal. Okay, this theorem you should remember, and this result you should remember. We'll be using this in the exercise. Angles opposite to equal sides. So what are the equal sides here? AB and AC. So angle, these angles, okay, angle ABC and angle ACB, okay, will be equal. That is what the theorem says. Angles opposite to equal sides. So first we will see equal sides. AB, right? AB and AC, these are equal sides. Okay, AB is equal to AC. And what are the angles associated with them? This angle B and angle C. So how will we write? Angle ABC is equal to angle ACB. Similarly, now angles opposite to equal sides of an isosceles triangle are equal. Now you replace this angle by sides. Okay, the sides opposite to equal angles of a triangle are equal, so converse. Okay, when angles are equal, so sides will be equal, and when sides are equal, angles will be equal. So in this way, you have to use this theorem, students, and we will start with the exercise 7.2. Just try first 2-3 questions, then I will explain you more. Study well. All the best.